Okay, today, let's do the 2020 MIT Integration B qualifying exam. This is a test for the people who want to participate in the MIT Integration B competition. There are 20 questions and you have to answer them in 20 minutes. Of course, it's going to take us longer than 20 minutes today because I'm going to explain all the steps for you guys. And I will suggest you guys go try the questions first. The link to the file will be in the description for your convenience. Okay, before we start, if you haven't learned all the integration techniques, then you should check out sponsor today, Brilliant. We are currently looking at the Integral Calculus course. Here, they cover all the integration techniques that you have to know, such as integration by parts and different kinds of substitutions. Taking a course from Brilliant is really fun because they will keep you engaged by storytelling and cool animations. Over the past year, they have built a whole new platform for their courses that takes interactivity to the next level. You will see hands-on activities while you go through their courses, and especially they have over 60 interactive courses in math and science, and they range from beginning level to advanced level. So you will be able to find courses that you like and you can start learning something new. And I have a special link for you guys, brilliant.org/blackpenredpen. If you use the link, you will have a 20% off discount. So go ahead and check them out, and I want to thank Brilliant for sponsoring this video. And now let's get started with question number 1. So for the first one, we see this right here, and we see the log, and they mean the log base e, namely the natural log, right? So to do this, of course, we can still use the log property. So I'm going to just break this apart as, I will just write it as ln. So ln2, and then I'm going to add it with lnx, and then over the denominator right here, x ln x, and then this right here is also the same denominator, x ln x. So this one's actually really good because you see this and that will cancel. And for the first one, we can just do a u sub, that u equal ln x. And du is equal to 1 over x dx, so that's pretty much it. And we have the ln2. And of course, on the actual thing, you don't really have to show all the steps. But anyway, though, I will show enough steps, right? Anyway, ln2 is just a constant, and then we will have to integrate we will have to integrate 1 over u, which is ln u, which is that ln x. So I will just actually put down a parentheses because originally we have natural log already. So that means x has to be positive. So we don't need to worry about inside being negative. All right. And then likewise here, we have to integrate 1 over x. So we just get ln x. And then that's it for the first one. So it's a pretty good one. And by the way, I don't think you need to put down the plus d either on the test, but I will still put on the plus d for you guys. So for the second question, I believe the easiest way is to just multiply the top and bottom by e to the negative x, and you will see why. Here we will just get the integral going from 0 to infinity, e to the negative x over, this is 1, this is e to the negative x, and then we have the dx. And right here we can just do a u sub, let u equal to the denominator, 1 plus e to the negative x, and then differentiate both sides. Du is going to be e to the negative x, but use the chain rule, multiply by the derivative right here, which is negative, and then we have the dx. Well, on the top we have positive e to the negative x. We need to have a negative in order to have the du, right? As we all know, a negative times a negative is positive. So just like that. Alright, so now we have the du right here, which is very nice, and we'll finish everything the u world. So this is the integral, and it's negative in the front. X is equal to 0, we put it here. You see that e to the 0 is just going to be 1, 1 plus 1 is 2. So right here we'll have u going from 2. Put infinity to here, e to the negative infinity is 0, and then we have just 1. Alright, and then we have 1 over, this is u, and then we have the du right here on the side. And then right here, we can use this negative to interchange the 1 and 2. So let's go ahead and do that. So we are looking at the integral going from 1 to 2, 1 over u du. And we can finish this in the u world. So we integrate that. We have ln u, and then we have to go from 1 to 2. And this is going to give us ln 2, and then we have to minus ln 1. ln1 is equal to 0, and this right here shall be red. So altogether, we just get ln2 for the final answer. And then that's it. For number 3, we will first do a u sub. I will let u equal the inside, which is ln x, and differentiate that real quick. We get 1 over x dx. And that's exactly what we have right here. So we'll take this integral to the u world. Well, we'll finish everything there. X is going from e to the e's power. you put e in here, ln is equal to 1, so you will start with 1, and we put e to the e in here. Well, ln and e cancel, but we still have one more e, so we will have to go to e right here. Okay, log x is our u, and we have log, which is the ln, and then this right here is our u, and the rest is just our du. So this is very nice. For this one, we can do integration by parts. Of course, we'll do the di method. So I will put down the d and an I right here, plus and minus. I will be differentiating this, ln u, and then integrating u. Do this, we get 1 over u. Do that, we get 1 over 2 u squared. So let's see what we have. First part of the answer is just this times that, which is going to be 1/2 u squared ln u. And remember, we still have to go from 1 to e. But the second part is still going to be an integral. And that's the integral when we multiply this and that together. So we will have to subtract the integral. I will just write it down right here. Subtract the integral of 1 over u times 1 over 2 u squared du. So let me just do the integration right here. We see that this and that cancel, which is very nice. So we just have to integrate. So this is minus, we have the 1/2 integral, and we have the u du. So it's going to be, the new power is 2, so divided by 2. So we get 1 over 4 u squared. So that's pretty much all we have right here. So I'm going to just put down the result right here. So that's minus 1 over 4 u squared. And then I will be plugging the numbers. We need e and 1. I mean, we need 1 and e. And let's see, when we plug in e in here, we get, let's see, 1 over 2, and then we have e squared, ln e is just equal to 1, so that's okay. And we put e in here, we have minus 1 over 4 e squared. So far, so good. And then we have to plug in 1, which is going to be 0, so that's no more. And we put 1 in here, we will just have a minus 1 over 4. And of course, let me just write it down so to make it slightly better, slightly nicer. But anyway, let's get the common denominator, multiply by 2 and multiply by 2. So this is going to be 1 over 4, positive. And then e squared, and then positive 1 over 4. So that will be our final answer, and we do not put on plus c because this is just a number for the definite integral. Okay, so for number 4, I'll first tell you that it converges, so you don't have to worry. We just have to compute it. And if we use the integral of ln u being equal to u ln u minus u, then this is going to be so much easier. And this is a rather standard integral that you should remember. Alright, so this is how I'm going to do it. I'm going to use the log property to break this apart. So we're looking at ln 1 plus x, and then minus ln 1 minus x. And you see that this right here will be our u for the first part, and this right here will be our u for the second part. But remember, if this is our u, I'll just put this down in blue. U equals 1 minus x, then in that case, du will be negative dx. So we do have to negate the result later on. Alright, so I'm going to just go ahead and integrate ln of 1 plus x, which is going to be this times ln u, which is that 1 plus x, and then ln inside with 1 plus x, and then minus u, which is that, which is the 1 plus x. So that will be the first part of the integration, and I still have to plug in numbers, but let's also take care of the second part. This was negative, but again, because we will have this negative, so we will actually just add the results. I will put this down in blue to make it stand out. Minus, minus become positive. Alright, so this is our u, so I'll put it here. I will have, put this down in blue and black. Yeah, that's blue and black. 1 minus u ln, and then 1 minus u, and still we will have to negate because I put a negative all the way outside already, so this is still, we will have to subtract right here, and we will have 1 minus x like this. Alright, so I think this is the kind of question that is there to waste your time, in my opinion. Yeah. So let's see, we are going to go from 0 to 1. Alright. Yeah, because speed is a factor for this kind of test, right? So definitely. And yeah, let's see. Put 1, this is 2, and let me just put this down like this. We have 2, and then ln 2, and then minus 2 because x is 1, and then when we put 1 right here is 0, when we put 1 right here is 0, so we are done for that first part. Not so bad. Now we are going to put 0. So when we put 0 in here, ln 1 is 0, so that's 0. And we will have to minus 1 right here, minus 1. And then put 0 in here, again ln 1 is 0, so that will be 0. And put 0 in here, we will have a minus and then 1. So we have another minus 1, like so. Okay, have a look. This is negative 2 and then plus 2. So in fact, this and those cancel out. So in the end, the answer is just going to be 2 ln 2. And if you prefer, you can also write it as ln 4 because you can put a 2 right here to make it into a power. So that's it. You know, I actually prefer indefinite integrals over definite integrals because we really have to know how to integrate when we are dealing with an indefinite integral, right? Because sometimes when we have the limits of integrations, we will have to think about some special substitutions and we end up with some magical number for the answer. But not for this one. And the way to integrate this is we will just multiply this out, combine items first on the bottom and see what happens. Here we have x squared and we will have another x squared here. So altogether we have 2x squared. And then the next term is minus 2x and then the last term is plus 1. This is a quadratic, but imagine if we have 4x squared minus 4x plus 1, then that will be a perfect square. That's actually going to be much better, so let's go ahead and make that happen. To do so, I'm going to multiply the top and bottom by 2. And we see this right here is going to be 4x squared minus 4x, and I know that's equal to 2, but 2 is the same as 1 plus 1. So I'm going to put down plus 1 and then plus 1. Check this out. We will have the integral on the top is 2, on the bottom here we have 2x minus 1, and that's a perfect square. And this right here is just going to be plus 1, and let me just make it into 1 square for you guys. Because this right here, we can now just do a u sub, let u equal that, which is 2x minus 1. And du is just going to be 2 dx, which is exactly what we have right here. So we just have to integrate 1 over u squared plus 1 in the u world, right, du. And that's going to give us inverse tangent of u. So let me just go ahead and write that down. And the u is of course that, so I'll just put down 2x minus 1. And we're done, so just put a plus c. That's it. Take a look at number 6. This right here is actually a lot of fun. Have a look. This is the integral, and then the first x is inside of 1 square root, so that's the same as 1/2 power. And this x right here, because it's inside of 2 square roots and they are multiplying, so we just have 1 over 4th power. And then this one is going to be inside of the 3 square roots, so we will have 1 over 8th power, and so on, so on, so on. In that case, we can see that we can just add out all the powers together. So this is the integral x to the 1/2 plus 1 over 4 plus 1 over 8, and so on, so on, so on. And now, here's the deal. If you have a piece of cookie, just eat half of it today. And the next day, just eat a quarter of it, right? Half of half. And then the next day is just a half of half of half, which is 1 over 8, and keep on going forever. This way, this right here is going to make sure your cookie, your one piece of cookie, will last you forever. So what I'm trying to say is that all this right here is actually just equal to 1. So we are just integrating x to the first power, so the answer is just going to be 1 over 2 x squared plus c. In fact, you could have gone from here to x to the first right away, because this is a pretty special, pretty well-known nested square root expression. So yeah, that's it. Okay, for number 7, it's a really long one, right? And again, I think this is just one of the questions that they put it there so that you will have to spend your time on it. But anyway, though, the way that I did it is I will multiply this out first. So we will get cosine square x minus sine square x. And I'm just going to keep multiplying them out. So we are looking at, when we do this times that, we will have sine to the 4th power x, and then cosine to the 6th power x. And then we will do this times that, we will have minus sine to the 6th power x and cosine to the 4th power x. All right. What do we do next, right? Here's the deal. The question cannot be too hard. It's hard, but it cannot be too hard. And whenever we have like two expressions like this, if it's like a sum or a difference, then just think about it. It might be a result of a product rule situation, especially see all the functions being multiplied like that. So what function are we talking about? Well, let's see. This right here, I'm going to break this apart. So I'm looking at sine to the 4x and then cosine to the 5th x and then cosine x. And if we look at it like that, we will see, isn't this like the derivative of something, right? Originally you have sine to some power, you brought the number to the front, and then because of chain rule you have that, and then that's like the second function. And let's see if this will work for the second part. If you look at this, and if you look at this as sine to the 5th x times sine x and then times cosine to the 4th power x, then don't you think that this and that is like the derivative of the other part? This right here stays the same, this right here stays the same. So it looks like, I'm just going to write it down right here for you guys. It looks like we're just differentiating the product of sine to the 5th x times cosine to the 5th x. Alright, let's see if it actually works. Of course, we need the product rule. Okay, I will first differentiate this function. So we are looking at 5, and then we have sine to the 4th power x. And remember the chain rule, so we'll multiply by cosine x. And then don't forget, we still have to multiply by the second function, and we don't change that. Hey, what's this? In terms of the function part, this is exactly what we have right here, except that we don't have the 5 right here, huh? But keep that in mind. Next, we are going to add, next we are going to differentiate the second function, which is going to be 5 cosine to the 4th power x, and multiply by the derivative cosine, which is negative sine x. And then we are going to multiply by the first function, which is just going to be sine to the 5th power x. And as you can see, this is exactly what we have right here, except for that 5. Well, we have to somehow get rid of the 5. How can we do that? It's okay, just multiply by 1 over 5 right here. Because when we multiply by 1 over 5, we multiply by 1 over 5 throughout the entire expression, so they cancel out. So, in fact, this is just the result of this derivative. So when we integrate that, we just get 1 over 5, and we have sine to the 5th power x, cosine to the 5th power x, and then we are done. So just put a plus c, and this is it. So for number 8, I actually have put it on my calculus 2 test before. It's a pretty fun one. We use integration by parts. So d and then the I, and then the plus minus on the side, we will be differentiating ln x squared plus 1 and integrating 1. Differentiating this, we get 1 over the inside, and then use the chain rule, so we have to multiply by 2x. And integrating 1, we just get x. And this is going to be the first part of the answer, which is x times ln of x squared plus 1. And we still have to multiply by this row here, and we still have to do that integral. So let's just take a look right here. This is going to give us a minus integral. I will put a 2 on the outside. X times x will give us x squared, and over the denominator, x squared plus 1. Well, how do we integrate this? This is x squared, that's also x squared. This is plus 1, let's go ahead and add 1. But that will change the whole thing. It's okay, just go ahead and minus 1, and then we'll be good. So we're looking at negative 2, and then we're integrating this over that is just 1, and then minus 1 over x squared plus 1. So we will have negative 2, and integrating 1 in the x world, we just get x. Negative 2 times that, which becomes positive, and 2, integrating this, we just get the inverse tangent of x. So that will be the result for the second part, and we'll just put it down right here. Minus 2x, and then plus 2 inverse tangent of x. And I will put down the plus c right here, because this is actually the question that we were doing. But if you guys want me to put plus c right here, that's fine too. That's it. Okay, for number 9, I don't think it's the super fair question, because If you know the formula, then you can get the question right. If you don't, then most likely you won't be able to figure this out right on the spot within that time period, because yeah, we only have 20 minutes to do 20 questions. And it's definitely not easy, all right? But I will tell you guys what the formula is. Here's the deal. When we have to integrate from 0 to 2 pi, and if we are talking about cosine to an even power, so let's say 2n right here, well, the answer is just going to be pi over 2 to the 2n minus 1 power, and then we multiply by 2n, choose n. So this is actually the answer for this kind of integral. Once you know it, this question just takes like 5 seconds. Right here, as you can see, we are looking at 2n. So in this case, n is equal to 1010 instead of 2020. Okay, so the answer will be what? Pi on the top over 2. And then we will just have to minus 1 to the power. So it will be 2019. And then we multiply by the binomial coefficient 2n, which is still 2020, and we choose just n, which is 1010. And then we are done. Do not put on plus c because this is a number for this definite integral. So if you're not happy because you think number 9 is not fair, then don't be too upset because number 10 is actually really easy. So I think this is how they make it up to you. Because we can just do a u sub, let u equal the bottom, which is 2x squared plus 2x plus 1. And then differentiating this real quick, we get 4x plus 2. And as you can see, this is just 2 times the top, right? So let's just go ahead and multiply the top by 2. And of course, we will have to divide this by 2. And as you can see, this right here is going to be the du. And we just have to integrate 1 over u, right? Okay, so we have that 1/2 right here all the way in the front, and integrating 1 over u is just going to be ln, and the u is equal to just that, so it's 2x squared plus 2x plus 1, which I believe is always positive, so we just need parentheses, and then we're done. Put a plus c, that's it. Huh? Just like that. I don't know if there's an easier way to do number 11. It took me a while to actually just read all the steps, right? So if you do know an easier way to do this, let me know. The way I did it is, we first do a u sub, let u equal the inverse sine x. So this means x is equal to original sine of u, and then just differentiate this. We get dx equals cosine u du. And of course, now we'll take this integral to the u world. When x is equal to 1 over square root of 2, you can put it here. We can look at this. Sine of what angle will first give you 1 over square root of 2? The answer to that is pi over 4. So we will be starting at u equals pi over 4. And then when x is equal to 1, we put it here. Sine of what angle will first give us 1? The answer to that is pi over 2. So right here, you will be ending at pi over 2. And on the top here is exactly our u, and on the bottom, x is the sine, so we will just have sine, and then to the third power, u, and dx is equal to cosine u du. So that looks okay, right? But what's next? We actually will have to use integration by parts. So let me put down the d and also the I, and plus minus plus. We will be differentiating u 1 time, 2 times, we get 0, and we can actually integrate the rest, namely cosine u over sine to the third power u. For this one, we can just do a substitution that says that w equals sine u, and the derivative of that is exactly cosine u, so we just have to integrate 1 over w to the third power, which is just w to the negative 3. Add 1 to it is negative 2. Divided by that, we get negative 1/2, and then that to the negative 2 power, which we can just write the sine on the bottom, but square that, of course. And if you look at this, this right here is just equal to negative 1/2. This is the same as cosecant square u. When we integrate negative cosecant, we get positive cotangent u, and then of course we still have that 1/2. So you see, it takes a while, and now the rest is you have to plug in number and all that stuff. Yeah, so definitely my least favorite one on this test. Anyway, I should stop complaining. I'm going to multiply this. So let's see. First we have that, and I'm going to write that down right here for you guys. We will have negative 1/2 u, and then I'll just write it as cosecant square u, and then this times that, which is minus 1/2 cotangent u. All right, then we are going to be plugging numbers. going from pi over 4 to pi over 2. Alright, check this out. When we plug in pi over 2 into here, let's just write down minus 1 over 2 and pi over 2. And this plugging into here is the same as plugging into here, and sine of pi over 2 is 1, so this part is going to give us 1, so that's pretty okay. And when we plug in pi over 2 into cotangent, cotangent is the same as cosine over sine. Cosine pi over 2 is 0, so that part is gone. So this is the first part. Minus the second part. Plugging pi over 4 into here and here, we get negative 1 over 2 and then pi over 4. And remember when we plug in pi over 4 into here, we get 1 over square root of 2 and the square that, which is 1 over 2 on the bottom, which is just a 2, right? If you look at the whole thing. So yeah, so we just multiply by 2 right here. And then when we plug in this into here, cotangent of pi over 4 is equal to 1. So we will have to minus 1/2 and times 1. Alright, have a look. We can reduce this, and in fact this is negative pi over 4, and this is also going to give us minus pi over 4. But negative minus negative, so plus, so in fact, yeah, the answer turns out to be really nice. This and that cancel out completely, and we have negative 1/2. So the answer to this integral is just equal to 1/2. So I highly suspect if there's any like a smart way to do this, and we just end up with 1/2 in like 2 lines instead of all this work. I don't know. So if you do know, please let me know. So once again, we will have to spend some time for this question, number 12. Well, first, I noticed that this is sine 2x, this is cosine x, so the angles are different. It's a good idea to expand it, and we can use the double angle identity, which is just 2 sine x times cosine x here. And you see now, we have cosine x here and also cosine x here, so I suspect that we should just do a u sub, right? So let's go ahead and make that happen. That u equal cosine x, and then we see du is just going to be negative sine x dx. Well, we see that this right here is sine x, but we do need a negative sign. So what do? Multiply by negative right here, and don't forget multiply by the negative on the outside then. So this is going to give us negative, and then we have the integral. And of course, we will also plug in these numbers into here. So when x is equal to 0, cosine 0 is equal to 1, so that means u is equal to 1. And when we plug in pi over 2 into here, cosine pi over 2 is 0, so u will be 0 right here. And let's see, here we have 2. This and that together is going to be the du already, so I don't have to worry about that. But we do have this, which is our u. And then we have cosine. And then the input here is again another u. And then finally we have the du right here. Whew. And then we are going to do, yes, this is like a standard question for integration by parts. And yeah, let's make that happen then. I'm going to use the negative to interchange the 1 and 0, but I will do that later. Let's do the integration by parts real fast. D and also the I plus minus plus, I'm going to differentiate to u 1 time, 2 times, and we'll be integrating cosine u. When we integrate this 1 time, we get positive sine u, and then do it again, we get negative cosine u, right? Negative cosine u. Okay, so this times that. First, we will have, I will just write down 2u sine u right here. And then next, we will have plus 2 cosine u. Alright, now check this out. I am going to be plugging 0 and then 1, because I use this negative to switch the numbers. And then now let's just do it. So when we plug in 1 first, we get 2 times 1, which is 2, and then sine of 1. And then plus 2 cosine of 1, and that's just how it is. Can I simplify that? And then when we plug in 0, this part is going to be 0. When we plug in 0, cosine 0 is 1, so we just have a 2. So the second part right here is just a 2. And that's pretty much the most that we can do. So I'm just going to take out the parentheses. So we have 2 sine 1 plus to cosine 1, you definitely don't need to do this part. You can just box the answer right here already. Yeah, but like that. So when I first saw number 13, what I did was just put down equal to 0, and that's it. Because I noticed that this is a definite integral going from 0 to 2 pi, and we have sine. Sine is an odd function, keep that in mind. But the biggest thing is that if you look at this, there's no way for us to integrate this with the integration by parts or any kind of substitution. No way. So I'm just going to put on 0 and then move on. Especially this is like a time test. If I'm actually doing this like to be qualified for the integration B, I'll just put on 0. It will be a really good guess. And then I would rather spend the time on the other questions. By the way, the answer is indeed equal to 0, and this is why. So we are looking at the interval from 0 to 2 pi. Let me just give you guys a quick graph. When x is equal to 0, you put it here, sine of 0, 0, minus 0, 0, so inside 0. So sine of 0 start right here. And look at pi, which is in the middle. Sine of pi is 0, minus pi right here. Inside of the sine, which is again 0. So this is a pi. And if you put 2 pi, you can guess it, you get 0. So give you guys a quick sketch, the graph for sine of x minus x. This right here. Of course, you can also put down like negative pi over 2, and you will see that this is going to give us 1, and then minus pi over 2, which actually is a negative number. So it's actually going to be like this. Somewhat like that. But I can tell you, this area is going to be the same as that area, but we're talking about integral, meaning that this is going to be a negative value, and this is going to be the positive value, and when you add them up, you get 0. Of course, you can prove it by plugging pi minus x into this function here, and then just work that out. But I think that should be good enough, so that's it. Okay, for number 14, this right here looks really crazy, but it's actually not so bad. Because the truth is, if we differentiate the bottom, we actually get exactly what we have on the top. Check this out. I'm going to let u equal the bottom, which is the summation as k goes from 0 to 2019. And we will have x to the k's power. And remember, this means x to the 0's power plus x to the first plus x to the second, and so on, up to x to the 2019. So when we differentiate this, the first term was x to the 0, which is just 1. Differentiating 1 is no more, right? So we actually have k starting at 1 and then all the way to 2019. And for this, we can just do the usual power rule. Bring the power to the front, minus 1. So we have k times x to the k minus 1. And then, of course, we should also have the dx. Now, this looks similar to that, but not quite exact, huh? Well, the way to do it is we can fix the index. So to do so, I'm just going to subtract 1, subtract 1. So k will be starting at 0 and up to 2018. But if I subtract 1, what we will have to do inside is, we will just have to add 1. So we get k plus 1 times x to the k plus 1 minus 1, which is just k. So this right here is exactly what we have on the top. Yeah. So it looks really crazy, but the setup was actually really nice. So now we see when we integrate the first part, we get ln absolute value of x minus 1. And then when we integrate the second, it's just, again, integrate 1 over u, which is use that. So we just get plus ln absolute value of the bottom, which is the summation as k goes from 0 to 2019 of x to the k's power. I doubt if anybody actually did this on the side, maybe just to do it for double checking, but like, yeah. Can we simplify more though? I think you should simplify it for the nice answer, so we will do it because technically we are done with the integration, but let's just simplify. To do so, this right here is actually the same as, well, we can just go ahead and do x to the, this, but you add 1, so it's 2020 minus 1 over x minus 1. So that's just the sum, and it's the finite version of the geometry series. And this is a logarithm, so it means that we can do ln of the top, which is x to the 20 minus 1, and then minus ln of the bottom, x minus 1. And have a look. This and that can be cancelled. Therefore, the answer is just ln absolute value of x to the 20 minus 1. And if you are taking the test in 2020, and when you see 2020, I think that's a pretty good sign. All right, put a plus C. That's it. Okay, for number 15, this is such a classic question. Go ahead and just write down this is equal to pi over 4. That's all. Seriously, it happens so many times in the past. Yeah, so classic. And I will just give you guys the general form for this. Notice that this is going from 0 to pi over 2. And the general idea is that if you have cosine to whatever power n, in fact, you can have sine right here as well, doesn't really matter. But if you look at tangent as sine over cosine, and then multiply top and bottom by the cosine of that power, then you end up with this form. So that's why I would like to put this down. Cosine of x to the nth power like this, and then over sine nx, and then plus cosine nx. I will just tell you this right here, classic. You see this, you recognize it, this is equal to pi over 4. I do have an old video on this already, so you guys can go check that out. But I'll just put down the answer and then we move on to the next one. So I think they gave us number 16 to make us feel good, because we can just do use up. Let u equal 1 minus x, and then move things around. I'll bring the x to here, and then look at this right here. It's going to be 1 minus u, and we'll differentiate. Dx is just going to be negative du. Now, take this integral to the u world. Here is the integral, and the x is equal to 1 minus u, and this is going to be u to the 20th power, and the dx is negative du. So I'll put down the negative right here, and then the du right here. And now to integrate this, put the negative down, we'll just distribute this. So we get u to the 2020 minus u to the 2021. And then, of course, we're in the u world. All right. So we will have negative, add 1 to the power divided by that, so 1 over 2021, and then u, which is that, 1 minus x, raised to the 2021st power. Distribute the negative, so we get positive here, and then add 1, which is 1 over 2022, and then u is 1 minus x, raised to the 2022. Yeah, plus c, that's it. So now for number 17, it looks pretty scary, but a simple u-sub can solve this. Check this out. Let u equal the denominator, which is secant to the 4th power x plus 4. Differentiating this, we get du equal, okay, bring the power to the front minus 1. So we're looking at 4 secant to the 3rd power x, and then don't forget the chain rule, multiply by the derivative secant. So we have secant x, tangent x, and of course the derivative 4 is 0, and don't forget to put down the dx. Now, you see that this times this, we get secant to the 4th power x, and then we have the tangent right here. What do we see? This right here is what we have right here, right? Okay, we have to have the 4. So let's go ahead and multiply this by 4 and divide it by it on the outside. So you can see that we will have 1 over 4, and for the inside, we just have to integrate 1 over u du, which is going to give us ln u, and that's going to be secant to the 4th power x plus 4, and this is always positive, so I just need to put down the parentheses plus c. Done deal. Oh my goodness, for number 18, we have x to the 2x power, but you know what? That's exactly our choice of u. So let's go ahead and write that down. That u equal x to the 2x power, and the way to differentiate this is to look at this x as e to the ln x power, and then we raise that to the 2x power, which we can just multiply this and that together. So let's put that down right here. Okay, so to differentiate this, we get du equals, first this repeats, e to the 2x times ln x, and then we use the chain rule, multiply by the derivative right here. And we need to use the product rule. So I'm going to derive the first, which is 2, and then keep the second. And then we are going to add, we are going to derive the second, and then keep the first. And as you can see, this and that cancel. Hey, this guy is exactly x to the 2x, which is this. This is that. This is that. You know what? When we differentiate x to the 2x, we get exactly this. So this means this integral is just equal to x to the 2x power plus c. Because if we differentiate this, we get that. So that's it. Alright, for number 19, one of my favorite questions, because this right here is just equal to pi over 4. And the way that we do this is that if you look at the graph for this, which is going to be a semicircle, but if you look at from 0 to 1, which is just going to be a quarter circle, and the radius right here is just equal to 1. So the area is just going to be pi divided by 4. And then we are done. Now, number 20, the last question. I think this right here is the hardest one because you actually have to know some calculus 3 stuff, namely the Gaussian integral. But I'm going to tell you guys that later on because we actually have to break this apart first. So let's make that happen. And the way that we can do so is to actually use integration by parts. So I will put down the d and also the I. And we have to think about this a little bit. Which part can we integrate? Have a look. Here we have e to the negative x to the 4th power. Alright. In order for me to integrate this, well, the best way is if you let u equal to this, which is negative x to the 4th power, and when we differentiate that, we get negative 4x to the 3rd power, right? So if we can have this, then we can integrate this. And the answer is just going to be e to the negative x to the 4th power. Perfect. Alright, so I put this down, and you see originally we have x to the 5th, and I put down x to the 3rd power already, so that means I can only put down x to the 2nd. But here we have negative 4. It's okay. Let's just divide it by that. And this is legitimate because if you multiply this and that cancel, this and that gives you this. So that's still okay. So that's how you can make things happen when you are trying to do integration by parts. Pick out the parts that we can actually integrate. Okay, differentiate this though. We get negative 1 over 2x. Okay. Alright, this times this, that's the first part of the answer. So let's go ahead and write down negative 1 over 4 x squared e to the negative x to the 4th power. Alright, and we will still have to integrate this part. Alright, let's go ahead and do that right here. So this is going to be a positive integral, and we are looking at 1 over 2x, and this is, check this out. Here we have e, and we have the x in the front already, huh? So I'm going to purposely look at the x to the 4th as x to the 2nd, and then squared, like so. Why? Because this way we can actually just do a simple u sub. Let u equal x squared, and we see that du is just going to be 2x dx. We don't have 2x, this is 1/2 x. That's unfortunately now okay, but don't worry. Just go ahead and multiply this by 2 and then divide it by 2. So I'm going to do like this. So you see, the 2x with the dx, that will give us the du. And then right here, remember this is going to be a positive. We have the 1 over 4, and we have the integral, and that's going to be the du. And here we will just have e, and then this is going to be u squared and the negative in the front. So negative u squared. Alright, let me do it again. E, negative, and this is the u, and then we have that square, and of course this and that is the du. Perfect. So that's the second part, right? So this is what you can do. You can put that back right here. And this is the first part of the answer already, so you can just go ahead and say plug in 0 and infinity. And then we are going to add the second part, which is plus 1 over 4 integral. And remember, we still have to go from 0 to infinity, and then we have that e to the negative u square du. Du in red, why not? Okay, this is the deal. First thing first. Plugging infinity to here, you see that we have e to the negative x to the 4th power that dominates. When you put that on the bottom, we only have x to a 2nd power on the top. That is much smaller compared to e to the negative x to the 4th power when x goes to infinity. So the first part is going to be 0, and then when we put 0 in here, that's also going to be 0. Yeah, the whole thing right here is just going to be 0. And then we are going to add, this right here is 1 over 4. This right here, ladies and gentlemen, it's not a whole Gaussian integral, it's just half of it, because it only goes from 0 to infinity. If we have the integral going from negative infinity to positive infinity of e to the negative u squared du, that would be square root of pi. But this is just halfway, right, from 0 to infinity. So we just have square root of pi over 2. Therefore, the answer is just going to be this times that. So we have square root of pi over 8. And this is it. Wow, 20 integration B qualifying integrals. A lot of fun. But I would say I can only get like 8 questions. Yeah, if you are giving me these questions, if I have never seen the questions before, and if there's a time limit of 20 minutes, I would be happy if I can get 8. Yeah, and maybe if I'm lucky I can get 10. So, what do you guys think about these questions? Let me know. And how many questions would you be able to get right? Have you participated in any integration B, and how is your experience? Just share whatever you want to share with me, alright? So, yeah, you guys can see I'm pretty tired. So, I would just say this is it.